Okay, this could be a question on the exam. You're given one line, and the question is to find the equation of another line that's parallel to the given line, but passes through another point. Okay? So, it's like this. You have this given line, and there's another point 3, comma, negative 1. I have actually no idea whether this is the correct graph, but it's just a conceptually. There's a line and another point, and your job is to find the equation of the line that passes through this point while being parallel to this other line. Pretty clear, right? Okay, now the question is, when do two lines become parallel in terms of equations? Yes?
When they like never cross.
That's what parallel means, but in terms of the equation, yes?
When they have the same slope.
When they have the same slope. In terms of line equations, parallel lines would always have the same slope. And that's the key. That's the one that we're going to use today. So, we will first have to find the slope of this line. And then, if you have the slope at a point, that's going to determine the line, right? So that's the idea. All right, so let's try to solve this. You have to find the slope. How do you find the slope of a given line?
What's the point?
You have to solve for y and convert it into slope-intercept form, right? So let's subtract 2x both sides so that you get negative 5y equals to negative 2x plus 7. So what I did was I moved the 2x to the other side and wrote it like this. Is this okay?
Yeah.
Now how do I solve for y?
Divide by -5.
Divide by negative y. So this will be negative 2x plus 7 divided by negative 5. Okay, the trouble is we solve for y, but this is still not in the slope-intercept form. Slope-intercept form must be something times x plus another number. So this single fraction must be split into 2. But lucky for us, we know that we can split a fraction like this. Right? See, if you have a plus b over c, that's the same thing as a over c plus b over c. That's something that we can use. Well, going that way might not be so straightforward, but if you go this way, it's obvious, right? If you have the same base, how do you add two fractions? The denominator only gets written once, and you only add the top. Is that right? Okay. So this is true, but because this way of going is a slightly challenging thing, some teachers use this terminology. If you do this and this, these are the two fractions, right? And this looks like a heart, right? So they would write something like share the love, share the denominator, share the love. Okay? And that's the way they train people, and it looks nice. I even wrote it in pink, so that counts too, right? Okay, so using that, I get that this is going to be negative 2x over negative 5 plus 7 over negative 5. But still, this is not a number times x. So what should we do? How can we convert this into number times x? Well, we just do it. See, negative 2x over negative 5 is just simply negative 2 over negative 5 times x. This is true. And the reason for that is when you multiply something to a fraction, it gets only multiplied to the top. You know that? When you multiply something to a fraction, it only gets multiplied to the top. So this is true. You're always, sometimes going in one direction in math is challenging, then just flip the direction and see if that makes sense. If that makes sense, then it's good. Are you okay? All right. But what is this? You divide negative by negative, what's that? Positive, so it will be 2 over 5x. Right? So using that, this can be now written as y equals to 2 over 5x. And then this minus can be pulled out and put negative 7 over 5. So this is what you get if you solve for y. What's the slope? 2 over 5 is our slope. That's the one that we wanted. Okay? So now that we know the slope of this, the question simply becomes the following. Give me a line equation whose slope is 2 over 5, which passes through 3 comma negative 1. If you're given a slope and a point, what do you use? Huh? Y equals mx plus b is one possibility, but point slope is the one that I really like. Okay, so let's use point slope. Okay. You can use y equals mx plus b and still get full credit, but this is the one that I'm trying to promote in this class. It's good for calculus, okay? So using that, what is x1 and y1? That's the given point. 3 will be x1 and y1 will be negative 1. You get that? So we're going to do y minus negative 1 equals, what's m? 2 over 5. That's the one that we just established. 2 over 5. And then x minus 3. And this is the answer. Okay? Now, I do this slightly differently. Most professors, and even your online homework, is going to ask you to go further. Okay? You have to go further by multiplying this out, changing this to y plus 1 equals to 2 over 5 times x, and then 3 times 2 is 6, so it's 6 over 5. And then you subtract 1 both sides, and you get y equals to 2 over 5x minus 6 over 5 minus 1. But 1 is 5 over 5, right? So this will be 2 over 5x minus 6 over 5 minus 5 over 5. And finally, this is going to be y equals to 2 over 5x minus 11 over 5. So that will be the answer. Is that okay? All right. Problem with this is, no, it's okay. All right. So this will be what you're expected, what you'll be expected in most other professors, but I like to stop here. I'll give you full credit if you do this on the exam. And the reason for me doing that is so that I can promote this formula. I want more people to be using this one than the other one. Yeah, so you could very well start with y equals to 2 over 5x and then plus b, and then you plug in 3 in here and then plug in negative 1 here and solve for b. That will be another way to do it. But that will be essentially the same calculation as what we're doing here, and it will be another painful calculation of fractions, which I'm exempting you by asking you to stop here. Okay, now let me just make one more point before I move on to the next one. I purposefully went from here to there in a very roundabout way because this is often what I observe students doing. They would just say, oh, solve for y, and they would just mechanically move the x to the other side and then divide, and they're going to do this, and that's not the most efficient way. That's what I want to point out. See, if you're to solve this 2x minus 5y equals to 7 for y, the better way is to move the 5y to this side rather than moving the 2x to the other side, because then the minus becomes plus, right? And you get 2x equals to 7 plus 5y. And now you subtract 7 both sides, so that you have 5y equals to 2x minus 7. Is that okay? Now the knowing minus sign in front of the y is gone, you don't have to be bothered by it. Right? So that's one tip. The second thing is, when you divide by 5, you don't have to divide by the entire thing. You can do term by term. And in fact, you can just divide by one of the coefficients. So you can divide 2 by 5, and then 7 by 5. And if you do it this way, there's a lot less headache. If you know the rules of the fraction as well, and if you know that dividing 2x by 5 is the same thing as 2 over 5 times x, then you don't have to go about first writing this and then doing the next step. It's a lot simpler if you do it that way. Okay? So I just tried to show you all this because this is like the possible pitfalls. If a student does it this way, often they get stuck in one of these places and don't know how to proceed. But this is supposed to be a very easy question if you do it the correct way. If you do it this way, it becomes a lot easier. Okay? So please do it this way. Any questions?